Hey, everybody, I'm going to be looking over in, hey, Chrissy, I'm going to be looking over in chat as we go along and presenting. You're writing a web application, and it's pretty interesting. It counts. And so you can walk up to it and you can click and the number can go up. And this is an interesting web application because obviously it's gorgeous. Even Chrissy would say that my CSS skills have gotten much better. But this is a little bit odd because if you go up to this and you take a look at the app, you'll see that it's actually doing something in Python in the browser. It's interesting because the way we've got it set up, I can write my stuff and I can make it go pretty fast. For example, I can say, exclamation, exclamation. It reloads pretty fast. And I can go to my JavaScript and I can change something to, not render it or put my current, I could save, it's got some JavaScript in it. I can go to the counter itself and I can have it maybe start a little higher. And I'm doing all of these things. I can reload. I'm doing all of these things and I get a great positive experience, but there's something better I can do for a positive developer experience. I can eliminate the browser part of this. And I could sit, for example, in a test and I could run my tests. And this is Python, so I can just run my tests and it failed. Of course it failed because, and I'll split right. I'll go back to my code. I changed it and broke my test. Now I can run my test again. If I was confused about that, I could put a breakpoint here and I could run just that test under the debugger and I could stop right there. I could step into my code and I could see that, oh yeah, it's starting at 0. That's why my test failed before. I'll continue on that. And I've got some code that also is in JavaScript. And I could go to my JavaScript code. And I could also sit here in a test for it. And I could run a test. I could run a test under a debugger. And I could exercise the JavaScript side of it. And in fact, it also is executing the Python side by running Pyodide. And I see that my count was wrong because I've got that label in there. And I could go and fix that. And my tests rerun. And I could walk up to a test and do a click. We'll see all of this a little bit later. All the work that I just did, I clicked around, I went through my code, I executed it. As Chris May would say, I did some refactoring. And I did it without a browser. I never went over to a browser. I stayed in my tooling and I had a really joyful developer experience. That's what I want to talk about today. A different way of doing front ends as we go into this world of Python in the browser. It's something I'm very eager to talk about. So I'll go quickly into introduction. Hi, I'm Paul. I'm a developer advocate at JetBrains. Best job in the world. If you ever, I like to joke that I'm surprised I should be paying them, not them paying me, but don't tell them I said that. And I want to talk a little bit about what I want to be doing this year is showing, oh, I forgot the book. How developers can be badass and how we can, as people in the Python community, get people to start using tooling to have a better developer experience. How can your tools help you stay in the flow as a developer? The modern front end world has really embraced this, and the world of Python, it still has to catch up. If we want this experience about Python in the browser to be adopted by front end people, we need to think differently, and we need to think about this kind of developer experience. So far, the world of Python in the browser, Python in WebAssembly, is really focused kind of on a, hey, I've got a REPL. Look how cool that is. And it feels a little bit like if you were to ship a app.py and just send it to your friend Sophie and she runs it and that's all great. But what if it's a larger application? In the world of Python, we don't ship things around like that. We have a lot more tooling that goes into it. And that's how we have to think about front ends. And so I'm going to talk a little bit about tooling such as Pyodide, which helps us get Python into WebAssembly, Python in the browser, but in other places as well, such as in Edge servers, or even it's starting to take over Docker. So in the cloud as well. And this new project called PyScript, which takes Pyodide and makes it friendly for humans, aimed at casual developers, scientific community. It's super exciting, the work they're doing. Anaconda is to be applauded for this. But I want to talk a little bit more about the way people in the front end world work these days. In the front end world, we see this in Python a lot, much to my chagrin. Python doesn't generate HTML anymore. It generates JSON and sends it to a front end in a single page application. And in that world of React and Vue and Angular and all the new ones coming up, they have needs for and expectations of tooling. And so if we want to bring Python into that world, we have to have a story for that developer experience. As it turns out, I think it's a pretty badass developer experience. And so I'm excited to talk about it, to include testing. I'll talk about this real quick. I don't come at testing from a eat your vegetables perspective. It's not because I'm a big believer in quality, as Jody knows. I do it because I'm lazy and I don't want to switch back and forth between the browser all the time. And we'll talk about that in just a second. So actually, let's go ahead and switch over to that. In the normal kind of prehistoric days of development, I'll get these turned off. I'll turn off my dev server. In those days, we would have an application that maybe had an HTML file. And for Pyodide or PyScript, we would download stuff from a CDN. Every time we looked at it, we go out on the network, get stuff off the CDN. And we might have a JavaScript file. And the JavaScript file might do some of this awesome Python in the browser stuff. Right there in the middle of your file, we're going to run some Python code, and we're going to import a module that we downloaded and imported, and we're going to get a message, etc. And maybe we would console log that message or something. But if we're going to go run this, I'll run this kind of the old school way. I'll go bring up Pyodide, or bring up Firefox. And I've got my application running here. Great. It's very simple. I want to go and make a change. I'll take out the, let's see. Oh, I'm in the wrong one. In this one. I'll walk up to it, say, hello, Pyodide, hello, world from Python. And I'll go back. I'll split screen these so that we can have them both on the screen at the same time. And I think it's because it's still on screen. All right. And I've got an HTML file, and it's going to load up Pyodide from the CDN. It's going to load a JavaScript file that I'm writing. And the challenge here is that every time I'm going to write this, it's going to reload from the server. It's going to reload from the CDN. And I could put a console log in. This is going to be an adventure. And I would kind of expect this to work. But when I do, I see it's undefined. Why is it undefined? Well, I'm getting into things related to debugging and staying in the flow now. So what would I do? I would console log something else. Maybe I would console log hello. And I would reload from a CDN. If I was on a slow network or on a train or offline, I'd be in real trouble. This doesn't really help me that much. So, I'll sprinkle in debugger. And I will reload and I will go over to my other tool, the browser, and I will poke around in its debugger. And I will see, oh, it's a proxy and I've got to do something different with it. And then I'll accidentally check in my code with the debugger and the console log statement. And then wonder, why isn't there a more joyful way of doing development than this? And that's what we'll be talking about today. Now, some of the challenges with this, I'll admit it, this is the normal way of doing development these days. In these early days of us bringing Python to the browser, because we haven't put to work the tooling that's available in front ends. But there's some challenges with this. First, I've got to set up some kind of local server. I've got to go and get stuff from CDN essentially all of the time. I've got these constant context switches between my editor, my smart editor, or my IDE, whatever it is that you're using. But then I got to go over to the browser. And if I don't have a reloading server, I got to reload the page every single time. And then I got to go to the console log, but then maybe I need to go inspect an element. And then maybe I got to go back and run a test. And then I got to go back to my editor and repeat the entire cycle. Another thing is debugging. If I want to stop what I'm doing, I've got a challenge because I'm going across this language barrier between JavaScript and Python. Where do I put my breakpoint? One side is doing the execution, but if I want to stop in the other side, that becomes a challenge. If I look at some of the code, for example, in the Python code that's running here, I write to the document. And if any of you do web development, I'll say it like this. That looks familiar, but that doesn't. I wonder how many of you just had the kind of inception experience I just had. Like, wait, which language am I in? Because that looks normal, but I'm in Python and I get a squiggly. That doesn't look normal, but that's a squiggly because I don't actually have JavaScript available in CPython. So I can't actually run this code in my Python tooling. Couldn't run Black against it. I couldn't run MyPy against it. I couldn't run Vitest against it because this is breaking the universe. And finally, a lot of what we're doing just isn't that competitive with modern front-end tooling. Hot reloading servers, super fast bundling written in Go or Rust, debuggers that have dependency tracking so that they only run the tests that matter. Yeah, Chrissy. Yeah, import.js what? Exactly. And so as all of us get really super excited about Python in the browser, all of us as Python developers and as some of you are JavaScript developers, we're going to walk up to this with a set of expectations, and it's just not there yet, and we need to make it. So mostly this talk is a call to arms for people who are interested in this to start working on it. So I'm going to go back to my larger application and walk you through a number of these points that are important on two sides. One, joyful development using your tooling. And two, let's all bring a better front-end experience for Python in the browser. And so my starting point on this should look kind of familiar depending on whether you're front end or not. I've got I'll collapse everything. I've got a package. You know it's a package because it has that. I adopted this instead of setup.py. This is using the setup tools back in. So I have switched to pyproject.toml. If you need to squint and look at this as setup.py. So that looks normal. If you do front-end development, you'll look at this and you'll say, that looks normal also. But I've also added some tooling from the front-end experience, primarily this thing called Vite. And am I still all right? Maybe, yeah, I'll leave you in there. And Vite is written in, of all things, Go, and it has gained a lot of mind share because it's super fast, very mature, even though it's quite young, has a lot of features. It presumes ESM, ECMAScript modules, meaning a sane import-export system that works on the back end and the front end. And that one decision is what got me to use it. It also supports TypeScript out of the box. There's a test runner for it called Vitest. And when I go back, you'll see that I have both Vite and Vitest as dependencies. So this is a little bit of a starting point. I've got a project. It's ready for normal practices in Python, and it's normal for regular practices in JavaScript. What are some of the ways that I can run this? I apologize. This is going to get weird. As a developer, I'm writing Python in the browser. I'm actually doing three things. I'm doing Python, I'm doing WebAssembly, and I'm doing JavaScript. And any one operation might involve a trip that way or that way through these systems. When I want to run it, obviously, I want to share it with Sophie so that Sophie can click my counter. And that's in a web browser hosted at a URL, everything that you think of for the web. But when I'm in development, things are a little bit different. When I'm in development, I might want to run my Python code with Python so that I can use Python tooling. That's pretty normal. Basically, I mean CPython. I want to reformat my code with Black. I want to run my Py on it. I want to run Flake 8, pre-commit, 57 other things on it. And I want my IDE to red squiggly me, to give me the refactorings that Chris talked about. In dev mode, I want a great Python experience. In dev mode, I want a great JavaScript experience. What that means is I'm not running in a browser anymore. I'm running in NodeJS or Bun or Dino or whatever, but I'm running in desktop JavaScript. And I'm running in dev mode, so I want different decisions made. I don't want to rebuild the universe. I want it to be really fast turnaround time. I don't want to copy everything to output. I don't want to bundle the crap out of it, all these other things. So I've got dev mode, and then I've got build mode, still in Node.js, but I want to hyper optimize things and produce a bundle that can be shipped to a server that Sophie can run in a browser. So all of these decisions are things that we have to think about a little bit. Let's see some of those ways to run it. So for example, I want to, hey, audience, do we want to do Python first or JavaScript first? I know there's a little bit of delay. I think you're all going to say JavaScript first. So what I will do is I will split screen and go back to having the Python counter over here, my test counter over here. And I want to be able to run this Python code in CPython. I just want to be able to walk up to this and run my test. Yay. I want to run my test under the debugger. Yay. I want to run just this test under the debugger. I want to set a breakpoint and stop there and make sure that my instance of the counter was what I expected it to be. All of this I want to do without switching to a browser, to this, to that, to the other, and have a very positive developer experience. So that's great. Many of you use PyTest. You know how all of that works. That's great. But I also want to test, and I want to do an end-to-end test of my whole system. And what I'll do for this is I'll go back to package.json and run the dev server. so that I can bring up test under pages, and I'm still in Python, so to speak, but I'm using Playwright. And I want to be able to do development, change my HTML, change my JavaScript, change my Python, black box test the whole thing while staying joyfully in my tool. So I can walk up to this test and I can run this test. It runs medium fast. It's not super fast. It's got to fire up Chromium in the background and go talk to my server, but it behaves as expected. And if I was in this mode, I could go over to, what is that, app.js? Yeah. And break it. And I could rerun it, rerun my tests, and I could see that I broke the contract during development. That was fast. That was faster and more joyful than going over to the browser, re-clicking the universe, 57 other things. So that's running all of this code from Python and doing it in a way that doesn't involve going to the browser all the time, but also lets me embrace some of the things Chris talked about. I really loved Chris's talk. The slide about normal versus good versus great is going to be in my head for a long time, that the great developers spend half of their time refactoring. I thought that was really great. And so I'm looking for a developer experience that encourages me to refactor. That doesn't mean I go over to Chrome and click the universe on every single refactoring. All right, so let's get over into JavaScript. The simplest way I would want to do JavaScript, actually, I will take a trip through another part of the explanation before getting back to the joyful side. In order to do this development and give something to Sophie, in the world of front ends, this means something called a bundler. It also might mean something called a transpiler, especially if you write in JavaScript. And so I need the ability to take all of my code, my CSS, my JavaScript, my images, whatever, package them up, make them available. Great, solved problem from a long time ago. In comes Pyodide. And with Pyodide, let's go to our setup Pyodide. Pyodide ships me a distribution. Very recently, they started doing it, that I can install using something called NPM. In my package dependencies, I can see I actually have a dependency on Pyodide. Great. I can get Pyodide from NPM, except Pyodide also has some binaries, the WebAssembly part. And this is a place that will get a little bit tricky. I know that we said that before. Yeah, it's going to get a little painful. What Pyodide does is it has some JavaScript. You load it in your application. Great. And then it uses fetch to go get that WebAssembly stuff. Fetch is a modern HTTP request in JavaScript. If I have my WebAssembly in Node modules, how is it going to fetch that? How do I get it into my bundled output so that Sophie can get to it? We need to make this easier for the population at large. I have done a quick implementation of a plugin for Vite, which copies the WebAssembly stuff, the WebAssembly stuff into the bundle. So for that, I wrote a test. And so that'll be our first unit test from the JavaScript side. I want to make sure that that works without having to rerun the universe, looking in the build directory, seeing if I got it right. The modern front-end world has good testing these days, just like Vitest. And I can walk up to this and I can run that test and see that my module dir function worked correctly. I could put a breakpoint here. and I can walk up to it and I can debug it. I'll stop at that breakpoint and I can look around, especially this one. Did that do the right thing? Hey, yeah, look, it expanded my directory completely. That's exactly what I wanted it to do. Thank you, debugger and test tool. A lot easier than poking around in Chrome. So I'll let that run. I can also, though, do this magic mode. And the magic mode is maybe the one thing I'd like you to walk away remembering. We talked about the testing tool called Vitest, blazingly fast. This is a front-end testing framework from the people that do Vite, same project. So it's got Go under the hood. So it's a lot faster than stuff written in JavaScript. But it's also fast because it only reruns things that changed. So if I go back to my testing, I can say, hey, run all of my tests, all my JavaScript tests, run them under the debugger even. And it's going to load up. Some of these are slow because it's doing Pyodide over and over. I'll show something for that at the end. All my tests pass. But what if I did that? Oh, my tests broke, and they broke fast. That's that watch mode. It knows only the thing that changed. Oh, okay. So now I got to rerun all the tests because that part is changed and everything depends on it. But what if I changed just this test? So that ran pretty fast, and that ran pretty fast. It's almost to the point where it's as you type execution. I'm writing code on the left. I've got a test on the right. I've got my test runner at the bottom. And as I code, it's always running. It runs in under a second. And I get constant feedback for these refactoring things that Chris May talked about. All right. That's a little bit about Python unit tests and JavaScript unit tests. I want to show a little bit about other parts of testing to get into the way I approach writing these applications. So for example, I've got an application where you click it and something happens. Let's see how we would test that. The test for that in app.test and the code for that in app. And in app, I have a event listener for click on the counter, and it runs update counter. Over here, I have a test that does a click and checks to see if the value went up. I can run this test and it simulates a click. So for it just ran. I could make it fail by saying, I think it should be 12. It's going to rerun and it's not going to be 12. I'll show in a second speeding up this part of it. I'll run just this test, just this one under the debugger, and I will put it back to the way it's supposed to be, but I will go over to Python code and tell it to increment by 10. Now, when I rerun this under the debugger, test is a little bit faster because it doesn't have to run so many of them. And it says, hey, no, you said it was going to be 1 here, but it's not 1. It's 10. Oh, it's over here. That's where the problem is. Now, how is it able to do this? I would like to point out, it's been a long time since I went to the browser. Am I right? How am I able to do all of this, including clicking, without having a browser around? In the world of Node.js, there is something called, I'll go back to the tippy top. there is something called Happy DOM. It's a successor to JS DOM. And Happy DOM is a simulated, I'll say, browser, a simulated DOM in JavaScript for Node.js, meaning tests. Instead of firing up Chromium, running something, destroying it, firing up Chromium, running something, destroying it, we'll do it very, very, very fast in pure Node.js. And I can also set breakpoints and stay in the browser for all this stuff. With that, I need to do some configuration and tell Vite, Vitest. I need to tell Vitest in a config file, hey, I want you to use this thing called Happy DOM. And in fact, I want you, before you run, do some, do some work to go mock that fetch thing so that you return the files I want rather than going out on the network to get Pyodide WebAssembly, do some other things. And then when it's time to do this test, I can happily sit in my test, set a breakpoint in my update counter, run this test. And if I'm confused about what's going on, it will stop right there in my test, in my IDE, in my tooling. I get autocomplete, the whole universe. I stay in the flow because I don't have to go to another tool, Chrome. I can use a browser in Node.js. I'd like to point out again, I haven't gone to a browser in a long time. So what I'll do now is I'll switch over to something that is a larger application. And if you have any questions, I am looking over in Slack. So if anybody's got anything, doesn't look like anybody has anything. Chris May, tell me if anybody's got any questions. I'm going to switch over to a larger application that is a little more complicated. Let me turn off all the things here. That's all right. This is an experiment I did with a 19-part Sphinx write-up on kind of a little component framework for Pyodide called Pyodide Components. And the thing I'd like to show is the test running. So I've got a variety of tests in JavaScript. Some of them are unit tests that don't involve Pyodide, don't involve execution of Python. Some of them do involve execution of Python. For example, right here, I'm running a test that says that this is pretty cool about Pyodide. Why don't we just do that real quick? Actually, let me show what I did there. The way that I've started to do development is I always, ABD, always be debugging, and put a breakpoint somewhere, press space, wait a second, and it stops there. And so I can actually say self.pyodide.run Python, and I'll say 22 plus 23. And I can evaluate, stop for a second, stop. We're sitting in an IDE debugger using a bundler written in Go, grabbing JavaScript that goes through WebAssembly to execute Python code on the fly. But that notwithstanding, on to the more interesting stuff. This is how fast all the tests run because I did a trick to reuse the same Pyodide interpreter throughout all of my tests and restore the state. Why does that matter? Because this can be a really joyful way to develop. I can sit with my code on this side. For example, the counter, and I can break the rules, and I can wait a second. I didn't break them enough, did I? I'll change the HTML to be bleh. And I can wait a second. And I can see that my code breaks because it didn't find what it was expecting. There's more, though, that can be talked about on this. I'm going to shift out of showing you joyful development, and I'm going to shift out of this is Python in the browser into what do we need to think about as practitioners that want to write these types of applications. There's the first aspect of writing larger applications. We in Python don't ship hello.py to people. We have a Py project toml, and we have a package with the dunder and init, and we package it and put it on PyPI and all those other kinds of things. So we got to think about TypeScript. We got to think about making packages and sharing them on NPM. This thing about event handlers is something that we have to think about across the boundary between Python and JavaScript. There's a way to do this development that I showed briefly for Fetch, where you can install mocks. If you are a Vitest person, you understand mocks are a thing, and you might fall into the Harry Percival camp of never mock. You might fall into a different camp and use mocks, but they do have mocks on the JavaScript side, and it can be really helpful in this environment where I have a Pyodide instance, which is slow. And maybe I don't want or don't even need to go through it on certain tests. I can put in a mock. Here's one that's really hard and really important. If you're writing modern web applications, you don't want to beach ball your users. That's considered a party foul. JavaScript runs on the main UI thread, but they have a facility called web workers to run compute intensive things in the background. Pyodide can run in a web worker, but you have to design your application for it. 2 days ago, Firefox shipped 1.11 that has support for module workers behind a flag. So this world is coming. And then finally, that issue that I showed about the red squiggly about importing JS in Python, that's a thing that we have to keep an eye on. Do we want, in this brave new world of Python in the browser, Pyodide, do we want our code to still run on the server? This experiment is a component model with pre-rendering, an approach that lets you do templating both on the server and in the browser, so that you can generate the HTML before Pyodide takes a second to fill the box up. Those kinds of ideas are things that we're going to have to think about. I'll switch over to Slack. Thank you, Chris, for gathering things up for me. All right. To Michael, yes, my head spun trying to write this damn talk. It's been a tough week. But what that means, it's a call to action for all of us. We can make this easier for civilians, and we should. If any of you are in the front end world and are bundlers and things like that, let's get together at PyCon or otherwise, and let's do a good job at helping people. Let's see. Yes, this is Syed. Long-term vision in terms of web dev with Pyodide, concerns about front end, etc. I'm so happy you asked that. I do give a talk on PyScript, and I try to pitch this as the web is a continuum between sites and apps. Python, the web development community in Python has outsourced its front ends to JavaScript now. I'm not happy about that. Wish we could do a better job at clawing some of that back. But people who are just making sites are doing them in React. And that's not smart. If you have an app, maybe you do a single page application framework. If you're doing a site, use normal HTML. If you're somewhere in between, Pyodide and PyScript can step in and give you a little bit more runway in Python before you have to outsource things to a JavaScript front end. That's my position. I'm sticking to it. Chris, I think this would shine mostly for Python developers. If you already like Python and like its tool set, you already have something in Python, and you would like to deploy it without making people go install Python, make a virtual env, do 57 other things. If they want to just walk up to a URL and consume your Python, this is a great solution for that. Anaconda is working on MicroPython in the browser, which is significantly smaller, much faster startup time. That will extend the runway a little bit longer. Pamela, that's great to see what you're doing for Pyodide and educational stuff. Hopefully we will talk more about that. And you do use a worker. Good job. Makes testing a lot easier. Okay, with that, I believe I'm 3 minutes away from being out of time. Thank you all for listening. Thank you all for caring about this topic. I went from here to there and got really low into the weeds about front-end testing tools and all the issues that you get into it. But I want to get back to the bigger picture. Python in WebAssembly is coming. It is supported. It's getting towards the browser. This is so remarkable for those of us who've been doing Python in the web for years. Let's all get involved. Let's do badass stuff with this. Let's help other people be badasses. Thanks for listening.